First up, the Virginia-class attack submarines with the Virginia payload module. These are not your grandfather's attack boats. Block V Virginias get a big boost in strike and payload flexibility because of the VPM, a long internal section that dramatically increases the number of Tomahawk-sized weapons the boat can carry and opens space for future large payloads. That means more distributed, stealthy strike capacity from under the waterline, a very hard target for anti-access forces to suppress. The VPM concept lets attack submarines do a job traditionally reserved for guided missile submarines while remaining quiet, survivable, and mobile at depth. Second, Columbia-class ballistic missile submarines, the sea's ultimate deterrent. While strategic deterrence is often discussed in nuclear terms, the operational effect is straightforward. A modern, survivable SSBN force forces any potential competitor to account for a secure U.S. retaliatory capability, complicating their calculus in crises. The Columbia program is the Navy's top shipbuilding priority, with steady procurement and large-scale industrial investment to keep a continuous at-sea nuclear deterrent well into mid-century. That industrial pipeline and the political will behind it also sustain submarine yards and suppliers that build the attack subs and future undersea systems that matter for regional competition. Third, long-range precision anti-ship and land attack missiles. Think LRASM, Maritime Strike Tomahawk, and the family of upgraded Tomahawks and future HELIOS/hypersonic concepts. Modern anti-ship missiles like LRASM bring autonomous targeting, hardened sensors, and data links that make it much harder for an adversary to hide capital ships or disrupt strike groups. At the same time, the Tomahawk family's recent block upgrades and the Navy's moves to field variants able to reach further and hit maritime targets restore the sub-launched and surface-launched long-range punch the fleet needs. When missiles can be launched from aircraft, surface ships, and submarines and updated in flight via data link, a defending adversary faces complicated, multi-axis threats over long distances. Fourth, integrated Aegis/BMD upgrades and the Standard Missile 6 family multi-mission interceptors that blur the line between air defense, cruise missile defense, and even terminal ballistic missile engagements. SM-6 is a flexible, long-range interceptor that the fleet uses for fleet air defense and for complex engagements where layered sensors and fire control are crucial. Coupled with Aegis software and cooperative sensor networks, these missiles let carrier strike groups and surface action groups threaten attacking aircraft, cruise missiles, and some ballistic threats long before they can reach critical assets. The continuing export and fleet-wide fielding of SM-6 derivatives is also expanding Allied missile defense posture in the Indo-Pacific, which strengthens regional deterrence. Fifth, directed energy weapons and shipboard lasers. The Navy has moved from experimental demonstrations to operationally relevant tests. High-energy lasers like HELIOS have been installed on test ships and successfully struck airborne targets in recent trials, demonstrating how scalable power-based weapons can complement kinetic systems. Lasers offer very low cost per shot against drones, small boats, and many incoming threats, and when integrated into a layered defense, they free missiles for higher-value targets. As power generation and thermal management on ships improves, expect directed energy systems to be an increasing part of close-in defense and distributed lethality concepts. Now let's unpack each of those 5 capabilities in plain terms, what they bring to the fight, how they change Chinese planners' dilemmas, and the limitations they still face. On attack submarines and the VPM, imagine a stealthy platform that can sit deep and invisible while launching precision strikes inland or at sea, deploy payloads and sensors, and carry special operations gear or future hypersonic canisters. The Virginia Block V boats with VPM give the Navy an undersea magazine that is both survivable and flexible, which is crucial in a scenario where surface ports and airfields are contested. For China, the presence of multiple quiet subs with increased strike loads raises the cost of concentrating surface forces and complicates their ability to use anti-access systems unopposed. The caveat is that submarines remain complex and expensive. They require forward support, secure basing options, and robust undersea maintenance to sustain high-tempo operations. On Columbia-class SSBNs and strategic effects, while these boats are not a tactical weapon for fleet fights, their strategic role has direct operational consequences. A credible, modern SSBN force means that if things slide toward large-scale escalation, the U.S. retains a short second strike capability, which in turn reduces incentives to pursue riskier gambits in peacetime and crises. For regional competition, the Columbia program also maintains submarine industrial base health, so the Navy can keep building and modernizing attack submarines and undersea unmanned systems. The program's funding and schedule are national priorities, which also communicates long-term U.S. commitment to maritime power projection on LRASM, Tomahawk block upgrades, and future anti-ship hypersonics. Modern anti-ship weapons close the gap between detection and engagement. LRASM's sensors and autonomy reduce reliance on favorable ISR conditions by finding and prosecuting moving targets in contested seas. The upgraded Tomahawk blocks and planned maritime variants give the subs and ships the ability to strike high-ALU targets at range. And the Navy's future long-range hypersonic or prompt strike programs designed to be launched from subs, surface ships, and aircraft multiply that problem by offering strike options that are far faster and much harder to intercept. Put simply, when defenders must guard against stealthy subs carrying many long-range missiles plus air and surface launched options, their fleet dispositions and coastal defenses become more constrained. But these systems also depend on resilient targeting architectures and secure data links. In a contested electromagnetic environment, their effectiveness can be degraded if contingencies aren't planned. On Aegis, SM-6, and layered missile defense, modern fleet defense is not a single missile but a network. Aegis ships equipped with updated radars, improved processors, and SM-6 interceptors create long-reach and flexible response. They can engage aircraft, incoming cruise missiles, and some ballistic threats. The integration of allied ships and land sites acting as sensors and shooters turns single ships into nodes in a larger continental defense web, a hard problem for any aggressor that wants to move large strike packages or take down carrier strike groups. The downside is that these systems rely on sensor density, secure communications, and sustained logistics to maintain coverage over wide waters. Building and networking those assets across the Indo-Pacific is expensive and operationally demanding. On directed energy weapons and lasers change the economics of defense. Shooting down a small drone with a missile costs millions. A laser can do it for the cost of electricity and system wear. Recent shipboard tests of HELIOS and similar systems show real progress. Ships are beginning to field weapons that can track, dazzle, and in some cases, physically damage small airborne threats and small surface craft. For operations near contested coasts, lasers give point defense layers a replenishable option to handle high rates of low-cost threats, like swarming boats or mass drones, before expending expensive interceptors on higher-value targets. But lasers have range, weather, and power limitations. They complement rather than replace missiles and guns. Unmanned systems deserve their own paragraph because they're a multiplier across the board. The MQ-25 Stingray tanker drone extends carrier strike range by refueling manned fighters, increasing the time and reach of carrier air wings. At sea, large unmanned surface vessels, medium USV, and extra-large unmanned undersea vehicles, the Orca/Xluv family provide options for surveillance, mine countermeasures, strike logistics, and even distributed lethality. Unmanned ships can risk contested environments in ways manned platforms can't, and they can host sensors or weapons that complicate an opponent's targeting. The Navy's Ghost Fleet Overlord and modular USV efforts are direct investments in this future. But the autonomy, command, control, and legal rules of engagement for unmanned systems are still evolving, and robust, secure data links are essential for these assets to be useful in a fight against a peer competitor. Let's be honest about limitations. None of these technologies is a magic bullet. Submarines are powerful but require maintenance, basing, and trained crews. Long-range missiles are only as useful as the sensors and targeting networks that cue them. Directed energy is promising for specific roles, but not a replacement for kinetic interceptors in bad weather or at extreme ranges. Unmanned systems offer advantages but depend on resilient communications and rules for autonomous action. The sum of these capabilities, however, produces a layered, redundant, and more resilient naval posture, precisely the posture needed to impose costs on an adversary seeking to dominate a maritime region. What does this mean for China's planners? It forces them to hedge. They must invest more in anti-submarine warfare, better passive defenses for their ships, more extensive sensor nets, and a more resilient missile defense umbrella. They also must worry about strike options. They cannot easily see or preempt quiet submarines with many long-range missiles, autonomous platforms that complicate targeting, and weapons that reduce the effectiveness of HELIOS attacks. That strategic friction raises the threshold for aggressive operations and buys time and freedom of action for U.S. and Allied forces. Operationally, these systems also change how the U.S. fights. Fleets will aim to operate dispersed but networked, trading concentrated vulnerability for distributed survivability. Submarines and long-range strike create dilemmas that reduce enemy freedom of movement. Lasers and missile defenses reduce attrition from low-cost threats. Unmanned systems increase persistence and reach without increased risk to sailors. Together, these changes reflect the Navy's move toward distributed maritime operations, fight in many places simultaneously, complicate targeting, and preserve high-value assets. A quick word on timelines and industrial reality. Some of these systems are already in the fleet or in active testing programs, while others are in the later stages of development and procurement. The Virginia Block V boats are being built and fielded. Columbia funding and procurement remain congressional and Pentagon priorities. LRASM and upgraded Tomahawk variants are in service or entering service. Aegis and SM-6 upgrades are shipboard realities. HELIOS and other directed energy systems have completed successful shipboard tests, and MQ-25 and unmanned surface/undersea experiments are advancing toward operational use. That mix of deployed and near-term systems means the Navy is not waiting years to shape the competition. It is already producing operational effects while future capabilities mature. So what should viewers take away? First, naval competition with China will be decided as much by sensors, networks, and logistics as by individual weapon lethality. Second, the technologies we discussed, submarines with extra payloads, long-range precision missiles, integrated missile defense, unmanned systems, and directed energy are complementary. Each fills gaps the others leave open. Third, the effectiveness of these tools depends on training, doctrine, allied cooperation, and resilient command networks. The hardware alone doesn't guarantee advantage. Finally, deterrence is built by creating dilemmas and costs for an adversary, and modern U.S. naval investments aim squarely at that objective. If you want a short recap, 1. Quieter, more heavily armed attack submarines with VPM make the undersea a lethal and survivable strike corridor. 2. Columbia SSBN's sustained strategic deterrence that shapes crisis behavior. 3. LRASM and upgraded Tomahawks restore and extend long-range anti-ship and strike options. 4. Aegis plus SM-6 builds a flexible, layered defense that complicates attacks. And 5. Lasers and unmanned vessels change the economics of defense and allow new operational concepts. Each of these matters on its own, and together they build a tough, multi-domain naval force. A few closing thoughts on allies and geography. The Indo-Pacific is vast, and no single navy can be everywhere. That's why Allied integration, sharing sensors, hosting logistics, and operating interoperably multiplies the deterrent effect. Weapons are important, but basing access, exercises, and partner capacity building turn those weapons into credible regional posture. If the U.S. and partners can network capabilities across the theater, The multiplier effect does as much strategic work as any single platform. Thanks for watching and thinking through this with me. If you like this deep dive, hit like and subscribe for more explainers on military tech and strategy. Drop a comment telling me which system you think will matter most in the next 5 years, and I'll cover it in a follow-up video. End of script.